if we can evaluate a linear or a quadratic or a rational or a cubic or any of those types of functions, we should also be able to evaluate what we call piecewise function. A piecewise function is one single function that is represented with two different equations. Oftentimes it'll be in an interval type situation. For example, if x is less than 2, we choose this function. If x is 3, we choose this function. If x is greater than 3, we choose this function. That's how we will break it up. When we evaluate a piecewise function, the first thing we have to do is determine which piece of the function to use. We will determine that based on what value we are evaluating for. Once we choose our piece, we'll plug in and evaluate. If we are given an expression as opposed to one single value to evaluate, we'll then simplify our expression. So let's look at some examples of our piecewise functions. So here's an example of a piecewise function here. It tells me that my one single function f of x is equal to x squared plus 2x if x is less than 1. However, if x is greater than or equal to 1, it's equal to x minus 4. So for part A, I'm asked to find f of 3. Okay, so first thing I have to determine is which piece of this function do I want to use. Well, since 3, the x value I'm given, 3, is greater than or equal to 1, I'm going to choose the bottom portion. So I'm going to say that f of 3 is equal to 3 minus 4. Notice I've chosen the bottom function and then plugged 3 in for the x value, giving me f of 3 equals negative 1. Doing the same thing for f of negative 2. First thing I do is choose which piece I want. Well, if I have an x value of negative 2, that means it's less than 1, so I'm going to choose the top piece. I'm going to ignore the bottom, and all I'm going to do is take that piece, and every time I see an x, I'm going to plug negative 2 in, giving me negative 2 squared plus 2 times negative 2. Well, negative 2 squared is 4. Positive 2 times negative 2 is minus 4, which gives me an answer of 0. So f of negative 2 equals 0. Looking at this last piece, now notice that here I was evaluating for a single value. Here I'm evaluating an expression. So I'm still going to look at one piece at a time. So I'm going to have 2 times f of 1. Well, what is f of 1? Well, it tells me to first choose my piece. Well, if x is greater than or equal to 1, I choose this function here. So I'm going to plug 1 into this function, 1 minus 4. Then I'm going to go ahead and drop my minus 3. How do I find f of 6? Well, I go to my piecewise function and I choose my piece. Notice I'm going to choose the bottom piece again since 6 is greater than or equal to 1. I'm going to plug 6 into my bottom piece, 6 minus 4. And then I'm going to drop my plus 9. So now I'm going to go ahead and simplify my expression. So I have 2 times 1 minus 4 is negative 3, minus 3 times 2. Notice I'm not distributing because the distributive property is only used if I cannot do what's in the parentheses. 2 times negative 3 is negative 6, minus 6 plus 9. Well, minus 6 is negative 12. Negative 12 plus 9 is negative 3. So this expression is equivalent to negative 3. I have 2 more examples here, both of them with evaluating an expression. Since you've now seen how that looks, if you want to pause it and try it, I would encourage you to pause this video now, try example 2. Watch me work through example 2. If you are hitting errors anywhere, notice where you're making those mistakes, so then you can pause the video again and try example 3 and try to clear up those mistakes and not make those same mistakes in example 3. All right, so looking at example 2. Hopefully you've had a chance to pause it then and try it. So first thing I have is to find f of negative 3. So first I determine my piece. Well, if x is negative 3, I'm going to pick my top piece. I'm going to plug negative 3 into that top piece equation. Negative 3 plus 1. Got it, okay? Drop down my minus 2. And now I'm going to find out what is f of 2. Choose my piece. Well, if x is 2, I choose my bottom piece since 2 is greater than 0. I plug 2 into x squared plus 1, and I get 2 squared plus 1. And now I'm going to figure out what is f of 0. Well, if I'm less than or equal to 0, I choose function 1, or the top piece of the function. So I'm going to plug 0 once again into x plus 1. And now from here, now that I've plugged everything in, now I'm just going to follow order of operations. Negative 2 minus 2 times 4 plus 1 is 5, plus 0 plus 1 is 1. Negative 2 minus 10 plus 1 equals negative 12 plus 1, so negative 11. Make sure when you get to here you're following those order of operations. So there's example 2. Once again, make sure you pause and try example 3. Example 3 tells me that I'm going to find f of 3 minus f of 4. So first thing I'm going to do is figure out what is f of 3. Well, 3 tells me to choose this middle function because that's the function I pick when x equals 3. Well, guess what? That's just a constant function of 2. It looks like this. So no matter what my x value is, notice that I get a y value of 2. So if x is 3, y is 2. So f of 3 is 2. Minus f of 4. I choose my function. X value is greater than 3. 4 is greater than 3, so I choose this. So I get 2 times 4 plus 1. From here I evaluate. 2 minus 8 plus 1. 2 minus 9 is negative 7. Hopefully you were able to get that. You will have some more practice problems to do on these piecewise functions. We will also learn how to graph these piecewise functions, so we are not done with them. So hopefully you didn't find them too bad.